There again. We will be doing a proof this time by mathematical induction. We'll take you through the whole proof. So we are going to try to prove the statement 3 plus 5 plus 7 plus dot 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 n plus 1 is equal to n times n plus 2 for n element of the natural numbers. So the first part is we need to prove the anchor, that is to prove that this statement is true when n equals 1. So the statement on the left side, we would just get the number 3. For n equals 1, well, when n equals 1, that just means really the first term. So the value of the first term is 3. The little dot 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 in the original problem means that that side is expandable or contractible. So we will only use the first term. The right side, n plus 2, we need to plug in n equals 1 and then evaluate that. So we get 3 equals 1 times 1 plus 2. Of course, 1 plus 2 is 3, and 1 times 3 is 3. So we have proven, since the left side equals the right side, that the anchor has been met, or the base case. So now that the base case has been met, we are allowed to move on to condition 2, which starts with assuming that the statement is true when n equals k, and again, that's called our inductive hypothesis. So all we need to do for this part of the problem is anywhere there was an n, we substitute a k. So we get the following statement. Next, we're on to the prove statement. Here I'm just writing a statement that I'm trying to prove. So all we need to do is anywhere there was an n, plug in k plus 1. So on the left side, I would 3 plus 5 plus 7 plus dot 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 2 times n plus 1. Well, instead of n, k plus 1. On the right side, we have n times n plus 2. Again, instead of n, k plus 1. And instead of n, k plus 1. Simplifying a little bit, on the left side, the 2 can be distributed to the k plus 1, giving me 2k plus 2, and then plus the 1 there, meaning 2k plus 3. And on the right side, we can just combine to make it k plus 1 times k plus 3. So to do the proof now, I'm going to start with the left side of my prove statement. And I'm going to attempt to show that it's equal to the right side. So on the left side, I have 3 plus 5 plus 7 dot 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 plus 2k plus 1 plus 2k plus 3. So note I've written all the statements, all the terms, on the left side up to 2k plus 3. But the part that's highlighted is the left side of the inductive proof. So since the inductive proof is equal to k times k plus 2, I can substitute the highlighted part with k times k plus 2, bringing down the 2k plus 3. Distribute the k, giving me k squared plus 2k. Bring down the 2k plus 3 again. Combine like terms, giving me 4k. Bring down the k squared, bring down the 3. And at this point I can factor. Tell me two numbers that multiply to 3 but add to 4. Correct. K plus 1 times k plus 3. So there you see it. I've now gotten to the right side of the proof statement, meaning that I can write my statement, my final statement. The 3 dots mean therefore 3 plus 5 plus 7 dot 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 2n plus 1 is equal to n times n plus 2 for all numbers n which are element of the natural numbers. At this point, the only thing left to do, celebrate success.